Hi, this is Greg Milligan. I'm the Office 365 lead at Microsoft Canada, and I got asked to do this hackathon for Mississauga Secondary. I thought I'd take probably a little more than 5 minutes, but we'll see how this video goes, and you can tell me if you like it. A little bit about me. I have a bachelor's in mathematics in computer science and what's called combinatorics and optimization. It's a fascinating branch of math from the University of Waterloo. I went there a long, long time ago. You can tell that I look a little older than well, yeah, we'll just leave it at that. And since graduating from Waterloo, I did co-op there, which was really cool. And then I spent a bunch of time working at IBM. I went and lived in the UK for a while and worked at Royal Bank of Scotland. I worked at Frito-Lay down in the US, and then I joined Microsoft actually 20 years ago. So I've been at Microsoft 20 years this month, which is really super cool. One of the awesome things about a degree in computer science, engineering, any of the tech fields, you can basically travel the world and work almost anywhere. The language of tech is generally English. You generally have certifications in technologies, and those are recognized all around the world. So that's pretty handy for being able to travel if that's what you like to do. But that's actually how I started. So that's me in grade 10. That's me in the back row there, right beside the teacher when I had hair. That was the one computer that we had in our entire school. That one had 16K of memory, 16 kilobytes of memory. The little device on the desk is actually a cassette tape, and that's where things were stored. And I found it really kind of cool. I wasn't all that interested in coding games like a lot of the other guys were, but I was really kind of interested in how it works. Assembler scared me. I learned BASIC really as my first language. And then once I got to university, then I realized assembler wasn't that scary, and I eventually learned that. I'd probably call my native language for programming C. I still think in C because I did a fair amount of that in university, but I can do a bit of Java and other things like that. So that's what it was like way back then. If you like learning new things, then careers in technology are super cool because there's something new every day. The other thing about technology is I sometimes tell people it's more like medicine. You have specialists in different areas, and you have generalists. The technology field is way too big for one person to know everything about everything. So it makes it really cool for when you get a whole different group of people together and you learn lots of new things. In a short period of time, we'll see. I wanted to talk a little bit about artificial intelligence. I talked at the school, I think 2 years ago when I was in, about this. This is actually a session I did for a bunch of universities out in British Columbia. So UBC and Simon Fraser and a bunch of universities had a conference. And I talked kind of current state of artificial intelligence. I also talked about some of the things to be concerned about. So I thought I would start with a quick little primer on what is artificial intelligence. The best way to think about it is AI is actually a set of technologies, right? So you'll hear these terms used interchangeably an awful lot. Once you get into the field, it's actually important to understand the difference between deep learning, machine learning, neural networks, and how they all roll into AI. So AI is that set of technologies, and then it's used to simulate or augment elements of human thinking. So that's vision, speech, language, knowledge, problem solving, etc. The hardest of those is general purpose problem solving. So general purpose AI, where you can ask a computer anything, we are still a long ways from that. But using elements of AI for things like vision or speech, language, etc., you've all seen that, right? In terms of being able to, listen and translate. Lots of technologies do that. So that's a subset of that. I'd share that one. Here's what's really cool about it, though. What's really changed, and a lot of it's because of computing power and amounts of data. We try to teach computers now in AI like you teach a child. And so children learn things just by absorbing tons and tons of data. And that's basically what we do. So you don't teach a program how to play chess. You basically let it play chess billions and billions of times so it can figure out the best way to win, right? So here's where you start, here's what success looks like, and then try a billion different ways to fail until you figure out ways that work. That's really what most of this works on in terms of. So here's a cool little example in terms of layers, in terms of how we train big data sets. with lots and lots of data. Some of these different neural networks have up to 150 different layers. And you use each of these to make a decision. You don't see these hidden layers in between. It's all in the code. But effectively, what you're basically doing is breaking apart all these little things and then saying, okay, because of this, at the very end, you're going to see that this is actually a Labrador. It's not a Husky. And you train this thing over and over again, looking at millions of images and correct it along the way. And then it goes, okay, now I figured it out. So it's just the way that this works. Here's a good example of some of the things that you can start to embed into programming. So you're not going to see AI as a separate system. You're going to see AI elements land inside existing programs. We're starting to already see that in things like Office 365 and Google and lots of fun things like that, Desire to Learn or Brightspace. And so here's an example where you're basically sending an image in and the machine learning is scanning that, comes back, looks at the picture, sees that the man is swimming, makes a decision, and you can see in there, for example, that it says that it is not adult content. So it can figure out that even though this person doesn't have a whole lot of clothes on, that they're swimming and that this is not inappropriate content. So you can imagine for a search engine where it's trying to do things around strictness of search results. And it's saying, yes, I think that's male probably because of the facial hair and looks about 27. So those are some examples. I love the emotion API. And so these things are APIs now. This is the really cool bit, right? So you don't need to actually build out the machine learning or the AI. You've effectively got an application programming interface or a layer that you can take an image, send it into, and then it comes back and says, hey, here are the things that I see a very small number for anger, right? 5.18 times 10 to the minus 8, right? So those people are not angry. But I do see surprise in there, right? So a likelihood of surprise, of 99.5. And again, based on looking at millions and millions of images. So we can start to do this in listening to words. We can look at images, all these things. Super, super cool. That sounds great, but it can go sideways real quick. And so here's some examples. So remember I said that these things learn by absorbing a whole ton of data. What if I don't give it the right amount of data? Or the right kind of data? Maybe the data that I'm giving it is based on all the people that I happen to see in my country or in my neighborhood or in my workspace. And so everything around language, everything around images, all those sorts of things. And you can see there, that was a Google blunder in terms of a couple of people that it thought were gorillas, super, super insulting and completely wrong. You can see over on the right, I think it's a group of colorful umbrellas. That was the Microsoft caption bot. It gets confused. That's that classic picture of the white and gold dress. You can see kind of behind my head there. Some people see it as blue and some people see it as white and gold. And sure enough, the Microsoft caption bot somehow thought that it was a cat wearing a tie. So when these things go wrong, they can go horribly wrong. There's certain kinds of dogs that get this thing super confused. And so you have to be really careful about the type of data that you train this thing on. The other example, this happened a couple of years ago. Then this was Microsoft built a bot called Tay and basically didn't teach it anything. And all it was to do was be on Twitter, of all places, and listen to input and then try to evolve effectively a little bit of generalized AI based on input from Twitter. So it started off being really nice. And then by the end, people figured out that you could just spam this thing and send it a whole ton of stuff and basically get it to start thinking bad thoughts. And so by the end, he's hating feminists and that Hitler was right. And this is just a piece of software, but it's taken input and it's learned how to basically be evil. And you can see a tweet down below that said, Tay went from humans are cool to full Nazi in less than 24 hours. This was the interesting thing. So why I bring these up is, there needs to be an entire group of people, really the next generation, that understands where this AI technology is going and can help make sure that it's learning in the right way. We need to have rules around machine learning and AI and what the outputs are and make sure that it's inclusive. There's just so much work to do on this front. So it's not the answer to everything. It is yet just another set of problems that we as a technology community need to go and solve. So I just thought I'd throw those ones out there just kind of for fun. And the last thing I kind of wanted to end with just here as I'm coming up on 10 minutes is, so you guys are having a hackathon. Guess what? So are we. I thought it was really funny. I got the invite from Nathan to do this. And hackathons aren't just in school. Microsoft has had a hackathon internally. We have 200,000 employees, and everyone is invited to participate in the hackathon. And so we'll do it physically. And in fact, if you've ever seen any of some of the immersive reader and some of the cool things that are in OneNote and in Word and a bunch of other tools for basically being able to do translation and line-by-line reading of words of documents and things like that from your OneNote or from Word and other stuff like that. All that actually came from a hackathon that happened in Seattle a few years back. Really cool. It was a kid who was trying to tackle who's my bad habit of mine, a young employee who was really passionate about dyslexia. And he was like, you know what, if we could come up with a way to take printed material, like on-screen printed material, and eliminate visual crowding, get it line by line, change background colors, do spacing, all these various other things like that to make it easier for students with dyslexia to read, this would be really cool. And they built it over a weekend in a hackathon. Amazing story. We still do them every single year, come up with amazing stuff. One of the latest ones that we've done down at the bottom is helping a nonprofit. So we call it Hack for Good. And we get Microsoft employees from all over the world and all different kinds of roles to come in, because this is the important thing, and you guys are learning this in a hackathon, is having skills from a bunch of different groups and a bunch of different mindsets can really help instead of everyone thinking the exact same way. And so hackathons are super cool. Like I say, we do one at Microsoft. And hopefully that was useful. A good little 10-minute little video, and hopefully that was good. Please stick with comp sci, engineering, technical fields. They are super useful, and it is an amazing industry, and we absolutely need new people. We don't have enough to hire, so it's not just Microsoft, it's Apple, it's Amazon, it's Google, it's all the big tech companies plus all the small tech companies. There just isn't enough talent out there. So please consider careers in tech. Thanks. Bye.